Alright, so today we're going to practice graphing polynomial functions and writing equations based on information. So we're just going to go through each of these examples and I'm going to explain how I get the equations and graphs that I'm drawing. The first one says write an equation of a polynomial that has zeros at 4, 0, negative 5, 0, 5, 0, and 0, 0. The leading coefficient is negative, then identify the end behavior. So I'm going to plot these zeros first. So 4, 0, negative 5, 0, positive 5, 0, and 0, 0. And we are told the leading coefficient is negative. But when I write my equation, y equals, I'm going to have a negative in the front. You can have any negative number you want. Let's go with 9. Now we have our 4 zeros, or x-intercepts here. And if the leading coefficient is negative, that means the right side is going to go down. Nowhere in the problem does it say anything about the right side of the function. Nowhere in the question does it say anything about the degree of this function. So you have an option here. You can have the left side go up or the left side go down. I'm going to make it go down. So my function over here has 1, 2, 3, 4 zeros. Over here, when we write the equation, we write x minus 4, x plus 5, x minus 5, and then for this blue 0 is just x. A lot of times what we'll do is when we write the functions is that we'll put this x, because there's no plus or minus inside this parenthesis, in the front. So another way to write this equation in the way that you would most likely see it given to you would be y equals negative 9x times x minus 4, x plus 5, x minus 5. And then our function just goes. Now, the end behavior, both sides, the left and the right, are going down. So it's as x approaches negative infinity, as x approaches positive infinity, y approaches negative infinity. All right, so let's look at the next one. Write an equation of a polynomial with x-intercepts at 3, 0 and negative 7, 0 such that as x approaches negative infinity, f of x or y approaches negative infinity, and as x approaches positive infinity, f of x or y approaches negative infinity. So this means that the left and right sides are going down. So both ends go down. Let's plot our x-intercepts. And both sides are going down. Nothing else in this problem says, this problem doesn't say anything about degree or a positive or leading coefficient, but since this end behaviors here, that tells us that the leading coefficient must be negative. So y equals negative, can be any negative number. And we have our zeros, x minus 3, x plus 7. So our graph can just look like that, which is a parabola, and you can see that this is a quadratic function over here. Oops. Let's look at the next one. Write an equation of a polynomial that could have a maximum of 5 turning points. So remember, turning points are when the function changes from increasing to decreasing. If we were to draw this out, we would have, and I'm going to erase this in a second, so we'd have to have like 1, 2, 3, 4, like we'd have to have 1, 2, 3, 4, 5, something like that. Let me erase this. And the other day we talked about how the number of turning points has to be less than or equal to the number of zeros. Honestly, I think the easiest way to do this problem is saying, hey, if we have 5 turning points, then we should make an equation with 6 x-intercepts. Whoops. 6 x-intercepts. What I'm going to do over here is I'm just going to plot 6 x-intercepts randomly. Now, if I were to connect this, how many turning points do we have here? 1, 2, 3, 4, 5. 1, 2. So then we can write our equation, y equals, both ends are going down, so our leading coefficient is going to be negative. And then I'm just going to write my 6 x-intercepts in intercept form. We had x plus 5 for this one. This one is at -3, so it's going to be x plus 3. This x-intercept is at -1, so it's going to be x plus 1. This x-intercept's at +3, so x minus 3. This one is at +5, so x minus 5. And this last one is at +7, so x minus 7. These types of problems can be confusing because there are so many different correct answers. For example, if you would have just made this a +4, the graph would have looked different, but we would still have 5 turning points. Write an equation of a polynomial with a double root at x equals 6. So as double root, this means multiplicity of 2. And remember, multiplicity means that in that factor, or x-intercept, we're going to have 2 as our exponent. This problem says nothing else about the leading coefficient or end behavior or direction. All it says is that we must have a double root at x equals 6. So I'm just going to do x minus 6 squared. And you guys know how to graph that. Now, this is a quadratic in vertex form with a vertex at +6, 0, and opens up. See, since it's a double root or has a multiplicity of 2, my graph bounces right here. Our graph goes down, 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 stops right here at the x-axis, and comes back up. Number 5, write an equation of a polynomial whose degree is 4 and has 3 distinct real roots, or x-intercepts. Remember, distinct means different. So I'm going to draw that part first. 3 distinct roots. I'm just going to go randomly 1, 2, 3. Now, a 4th degree function means that if I were to write it out in intercept form, we must have 4 sets of parentheses. right now we only have 3 zeros. That means one of our intercepts or zeros must be repeated or have a multiplicity greater than 1. Kind of like how we have the double root here. This has a multiplicity of 2. We're going to use something like that down here. What I'm going to do is I'm going to try to find a way to connect these dots. Degree 4 means the ends must go in the same direction, so I can't do this. So don't write this down. I can't do this because the ends are going in opposite directions. 4 is an even number. My graph must have ends going in the same direction. So if this sign goes up, that means this sign goes up. And so now if I come through, I come back and touch that 0, come down and touch that. So this graph fits my directions. This is a 4th degree function with 3 distinct zeros. So now let's write the equation. Y equals, we have a 0 at -5, so x plus 5 is our factor. We have a 0 at x equals -1. Sorry, x equals +1, so we're going to write x minus 1. Then we have a 0 at +6, so x minus 6. And because our graph bounces right here, see our graph comes down, touches the x-axis, and comes back up, we're going to put a 2 there. Just an even number for multiplicity means that we're going to bounce. Let's look at the number of turning points. We have 1, 2, 3 turning points. So this point right here is a turning point and an x-intercept. So these types of questions can be difficult because, like I said, there are so many different correct answers. I always start with trying to figure out what zeros will I have, and then looking at the rest of the direction to see what kind of choices do I have to make and what kind of choices are already made for me. Like up here, where it didn't tell us that up here that both ends had to go down, but down here it did in the end behavior. Let's look at number 6. So we're going to write the following polynomial in standard form. As we've been doing this for a while, we can either do the box, or you can FOIL it if you're familiar with that. You have x squared minus x minus 2x plus 2. So our standard form is going to be y equals x squared minus 3x plus 2. My degree, that's the highest exponent, 2. Leading coefficient, there's an invisible 1. And end behavior. So the left side is going to go up, and the right side will also go up. Because our leading coefficient is positive and our degree is even, that means that the ends are going to go in the same direction. This leading coefficient of 1 means that that direction will be going up or in the positive direction. All right, let's look at 7, 7, and 8. So our equation, we have 1, 2, 3 different x-intercepts. And how many turning points do we have? 1, 2. So I'm going to write the equation y equals, and I'm going to start with my x-intercepts. There's an x-intercept at -2, so x plus 2. There's one at 0, so just x. and one at positive 1, so x minus 1. And then I look at my zeros and see, am I crossing the x-axis anywhere? Nope. So that means I won't have any even multiplicities. Now I look at my end behavior. The right side is going down, which means there needs to be a negative sign in the front. So if you wanted to rewrite that a little bit neater, negative 1 equals. You could have odd exponents up here because our graph crosses at these x-intercepts. So if you had like x minus 1 to the third power, that would still be a correct answer. Or x plus 2 to the fifth power, and then x to the ninth. That would still be a correct answer for this question because all of these exponents are odd. So again, there's more than one right answer. Number 8. Write a possible equation for the polynomial below. So again, I'm going to look at my zeros. I have 3 different x-intercepts. I have 1, 2, 3, 1, 2, 3, 4 turning points. So now I'm going to write my equation. Y equals, the right side is going down, so negative out in front, and x for this 0 plus 5, for this 0 x plus 1, and for that 0 x minus 2. Now we have to deal with our graph bouncing here and there. So at these two zeros, the exponent for those zeros must be even. We can make this a 2 and this a 6, or any even numbers, because our graph bounces here. Our graph goes down, touches, and comes back up. Over here, our graph is coming up, touches, and comes back down. And so you really need to determine at your intercepts, are you crossing, like right here, we're crossing the x-axis at this 0. But in my two areas over here, we are bouncing. So then number 9, we are going to skip number 9 because that's just a whole lot of math that we really don't need to do today. So we'll cross it out for now. So that's it for this lesson, for these notes. Make sure that you are attempting the homework and at least doing the parts that you know how to do. For example, up here, okay, if you know you're going to have these two intercepts, you at least can do part of this problem, even if you have no idea what this means. For something like number 1, you have 4 zeros. You can at least get your 4 zeros written down. If this part doesn't make sense, that doesn't mean you can't have something written down for the rest of it. So as you're going through the assignment, again, do the problems that you know how to do. Do the parts of problems that you know how to do. Don't just leave everything blank and say, I'm totally confused. That won't tell me what you need help with. Right? So good luck, work hard, and I will see you guys when I come back. Bye.